Hello and welcome back. Today we're reacting to some more Kurzgesagt. Today we're going to react to the black hole bomb and black hole civilizations. I think it's fitting because the last one we reacted to, or one of the last ones we reacted to rather, was about destroying black holes, and it was really interesting. So let's do something else about black holes. Let's hop right in.
Black holes are the largest collections of pure
Pac-Man.
violent energy in the universe. If you come too close, they'll devour you and add your energy to their collection. And so the energy is lost to us
That was
forever.
a cool
Or is it?
animation.
It turns out there's a universe cheat code. A way of powering civilizations until the very death of everything, or of constructing the largest bomb in the universe.
How do you turn a black hole into a bomb? I'm just thinking through the title. Black hole civilizations make a little more sense. You could potentially harvest energy from them for a very long time to support a civilization, way after all the stars die. But how would you turn it into a bomb?
But how? Didn't we learn that all energy is trapped forever in black holes, even light?
Ah, you don't put the energy into the black hole. You just accelerate it with whatever that's called. I forget, but basically the slingshot maneuver, right? Because you can steal some of the energy from it in that fashion, which is why we slingshot spaceships around planets. I forget what that's called, but there's a term for it. I'll bet you that's how we're going to make our bomb.
This is true. Everything you think you know about the weirdest thing in the universe is about to get weirder for one simple reason. Black holes are spinning.
Yep. That's the thing about learning about black holes, is when you first start talking about black holes, and if you get into it more and you start doing like actual calculations and everything, it's so much easier to think of black holes as not spinning. But in reality, every black hole should be spinning because it came from something that was spinning, and that angular momentum has to be preserved. So unless enough stuff goes into it at the wrong angle with enough energy to actually counteract all of that, which is, I mean, that's got to be dang near impossible, it's going to be spinning. Dun, dun.
Why black holes spin? When really, really massive stars die, their cores collapse under their own gravity into black holes. This means something very big becomes very, very tiny. Like the tiniest anything can be in this universe. But stars are rotating, and a fundamental property of our universe is that things that are spinning don't want to stop spinning.
The conservation of angular momentum.
And this angular momentum can't go away. A big thing that spins and becomes smaller spins faster. So, as the core of a star collapses...
If you've ever watched skating or someone skating and they do a spin, you can see very, very clearly if they start bringing their limbs in, their arms, their other leg, they speed up. And if they start reaching out, they slow down. That's a real life illustration that a lot of us have probably seen of this exact concept.
Its momentum makes it spin faster and faster and faster until it collapses into a black hole. And the black hole keeps on spinning, inconceivably fast. Some of them spin millions of times a second. Why spinning black holes are special? Just like non-spinning black holes, spinning black holes have an event horizon and a singularity at their core.
Well, think about it. When you see people that are skating do that, and they stretch out, and then they bring everything in close. Think about that. If you've seen that in real life, how much faster they spin when everything's in there. Now imagine if they could take their body and shrink it to a Planck length, which is the smallest unit of measurement that makes any sense to actually measure. Imagine how fast they would be spinning. Now take an entire star, a massive star with an extreme amount of mass, and shrink that down to a Planck length, or smaller potentially. We don't know. Singularity. Yeah, that's mind-blowing right there.
Where all of their mass is concentrated. The singularity is usually described as a single, infinitely small point with no surface area. But points can't rotate, so a rotating singularity can't be a point.
I think that I just want to get this out before they cover it, if they're going to say this, but I think that they usually represent the singularity as a ring, right? When they're talking about rotating black holes. So for simplicity's sake, oftentimes they refer to it as a point, but once you start adding more rotation in there, that's when the ring part comes in. And they have a crazy name for it that I forgot, but the ring singularity, or I don't know. In reality, though, and this is kind of more of a personal opinion of mine, but I believe that there's some people much more educated than I am on the topic that agree with me here, is when we talk about a singularity, it's not in actuality a single point of infinite tininess. It has to have some actual dimension to it. Maybe that dimension's smaller than makes sense to us with our limitations, but it has to have some sort of actual measurement. It's not infinitely small. If it was infinitely small, it wouldn't exist, right? So when we're doing our mathematics and our calculations and our numeric representations of everything, the best that we can represent it is by infinity. But technically, infinity should not exist in the physical world. So that's a flaw somewhere in our understanding or in our ability to represent the singularity. Not that it's actually infinite. But take it or leave it, that's an opinion, and I'm not a scientist.
Instead, it's a ringularity.
Ringularity.
A ringularity is a ring with a thickness of 0 and no surface, spinning extremely fast, containing all the mass of the black hole. The black hole is spinning so fast that it morphs space and time itself. It literally drags space with it, such is its power.
Yep.
This creates a new and super weird region of space-time.
Ergosphere.
The ergosphere.
I remembered!
Which the black hole. If space
I'm so proud of myself for that, actually.
Space and time are completely broken inside the event horizon, then they're only half broken inside the ergosphere. Inside the ergosphere, nothing makes sense. It's possible to enter it and then leave it again.
It's not the event horizon.
Great experience. You can imagine it like this. Falling into a static black hole is like sliding down a hole.
Yep.
Being inside the ergosphere of a spinning black hole is like spiraling down a deadly drain. The
It's a
black
good
hole
analogy.
transfers its own kinetic energy in the form of rotation to everything that enters the ergosphere. The ringularity makes you dance whether you want to or not. You need to move faster than the speed of light just to stand still here, which is impossible. But here's our cheat code. We can steal this energy. And there's a lot of energy to steal.
Because if you enter it not going straight, but if you enter it at an angle that's complementary to the rotation, you should be able to dip in and dip out. You're not traveling against the flow. That would be impossible because you'd have to travel faster than light. You're traveling with the flow. Dip in, dip out. And when you do that, it's possible to steal a little bit of energy, of rotational energy, from the black hole, which is genius. But even still, how do we turn that into a bomb? I'm still not getting that part.
How to steal energy from a monster. Take the supermassive black hole at the center of the Milky Way.
Okay.
We could steal as much energy from it as every single star in the Milky Way emits in 1 billion years combined.
Wow.
The easiest way to steal this energy is, oddly enough, to drop something into the black hole. We've seen that the ringularity forces energy on us when we enter the ergosphere, which is a lot like being in a whirlpool with space-time rushing around and around. If you're clever, you can use the water to your advantage and swim faster than before.
Yep.
In practice, this means sending a rocket into the ergosphere and making a trade with the black hole. We give it some mass energy, and it gives us some of its rotational energy.
See, that was the part that I was missing in my earlier explanation. That was the part that I had overlooked. It has to be an exchange, right? Because energy doesn't just come from nowhere. You have to exchange it. But E, energy, equals mc squared. The M stands for mass. It's it's amazing. It's amazing. It really is. You drop off a little bit of mass, you get a little bit of energy from the angular momentum. It's perfect. That allows you to dip in and dip out. Once again, you're going complementary to the rotation, not against it.
But it's not a fair trade. We get the better deal. Normally, if you fire a rocket, you exchange chemical energy for kinetic energy.
Yeah, I'm sorry, I'm pausing a ton here, but that's also another very important thing to remember is there's different types of energy. There's mechanical, there's chemical, there's potential, there's, did I say kinetic already? I don't remember, but there's different types of energy and you can exchange between them.
This is like pushing yourself forward in a swimming pool. But if you fire a rocket inside the ergosphere, it's like pushing yourself forward in a wave pool. The rotational energy of the waves gives you a much stronger boost than you could get just by pushing yourself.
Yep.
The boost from the rotation of the black hole is so big that you leave the ergosphere with much more energy than you entered it. The black hole gives a tiny amount of its rotational energy to you and slows down a little.
Insignificant
Obviously, this
to the black
requires a
hole.
lot of food. Fortunately, black holes aren't picky eaters. An advanced future civilization would probably harvest asteroids to drop them into the black hole when they needed an energy boost.
So are we talking about like a kinetic bomb here? Like the rods from God? That kinetic secret weapon that the US government tried to develop? Actually, I believe they did develop, but as far as we know, never deployed because it was impractical. But it's a kinetic weapon. It's not really a bomb, though. How do we make this into a bomb?
But there's an even better way to get energy from a black hole, and oddly enough, it builds the biggest bomb any living thing could ever hope to build.
Pinky in the brain!
The black hole bomb.
Fitting.
We only need two things to build a
very
black
fitting.
hole bomb: a fast spinning black hole and a big mirror. The mirror has to completely envelop the black hole, which is similar to a Dyson sphere.
It's clicking for me now, I think. But wait, no, I'm still missing something. I was thinking we could do it with light, right? Like a laser, and literally just speed it up so much around the black hole, bouncing back and forth. But where's your trade-off there?
A megastructure that harvests the energy of an entire star.
I'm missing
Although
something.
our mirror would be easier to build. Mirrors are simpler, and black holes are much, much more compact than stars.
Yeah.
If we made the mirror 10 centimeters thick, the metal of a big asteroid would probably be enough material for a black hole with the mass of our sun.
A lot of asteroids.
Once our mirror is in place, we only need to open a window and shoot electromagnetic waves at the black hole.
Electromagnetic
You can imagine
waves.
what happens next by imagining tossing a ball at a wall and it coming back faster than a bullet. The waves hit the black hole at light speed. A small proportion of the waves falls past the event horizon to disappear forever. But a much larger amount sloshes through the ergosphere, where the black hole forces some of its rotational energy on them and amplifies them.
Oh, so you're getting less waves out than you're sending in because some of them are falling in, and there's your trade-off. But the waves that you're keeping that you're eventually going to get out or let out have been stealing energy from the black hole. So they are much higher energy than and focused than the sum of what you put in, right? That's insane. It's actually scary. How much energy could you get this way? You could actually make a death ray.
They now begin super radiant scattering, which are fancy science words meaning bouncing around between mirror and black hole and getting stronger. Every time they go around, they are getting exponentially stronger. By opening some windows in the mirror, we can extract the energy from the waves as fast as they grow, which we could use, in theory, to create what would be, for all practical purposes, an endless source of energy for trillions of years.
Wow.
Or we could blow it up. If the waves are not released, they will continue to get stronger and take more and more energy from the black hole until the mirror shatters. A supermassive black hole would release as much energy as a supernova, making the bomb the largest explosion any living being could ever create.
That much energy? Supernova levels? Really? Supernova levels. I'm not buying that. Are you serious? Is that for real? I mean, these guys do their research, so I guess it must be, but wow. Knowing that we could theoretically create a bomb, so to say, that's on par with a supernova. I don't think we should mess around with that one. Just saying. We should maybe not mess around with it.
The last home in a dying universe. The beauty of the black hole bomb, the Penrose process, and the super radiant scattering is that they are not science fiction. In the far, far future, this might be the only way to survive in our dying universe.
Yep.
After all the red dwarfs have cooled down and all the white dwarfs transformed into black dwarfs, the universe will turn dark forever.
Can you imagine a species in the very, very far future is surviving in this method, right? They're living off of a black hole and the sky is dark. There's nothing out there that can be seen anymore, light-wise, because the universe is receding faster and faster and faster as expansion just keeps exponentially growing. And all the local stars that are nearby that should still be visible, they've all burnt out into their own black holes. And when they look at the sky, by that time, trillions of years in the future potentially, there's no trace, no idea that there ever once was huge, amazing, beautiful, glowing galaxies. That's sad. It really is. It's sad.
Rotating black holes might be the only sources of energy in the entire universe that life could harvest. If so, the last living being in existence might one day end its life around a black hole, which is equally chilling and uplifting. It turns out that even without any light, there are places we can go.
Eventually, there will be a last living thing. It will happen. And it very well could be living around a black hole. That is crazy.
Black holes are as interesting as they are mysterious, but there's actually a surprising amount we do know. Using maths, we can calculate things and come up with theories about how we die if we fall into them. If you're the sort of person who gets excited about math,
man, this video was amazing. I can't believe I haven't seen this one before. Like this was just so mind-boggling and thought-provoking, and it kind of conjured up some like deep philosophical thoughts too, which is not something that you often get from videos about black holes. But wow, this was really good. I actually quite enjoyed this one. Well, anyway, thank you so much for watching. I really appreciate it, and I hope you have a great day.